Hello everyone and good day once again. In the last video, I've shown you how to use the binary table that we have formatted in order to convert a decimal number into fixed point representation. In this video, I'm going to use the same binary table and the same example in order to illustrate how to convert fixed point values into floating point values. In the past, we used the continuous division process using decimal first. Decimal first because we divide the decimal value continuously by 2 until we reach an integer part of 0 so that the mantissa becomes fully fractional and the number of times that we divide the value is called the exponent. Now, I'd like to emphasize that we can use the same division in binary numbers. And in fact, it's much easier to divide a binary number by 2 or multiply it by 2 because it is equal to the base. Unlike in decimal, where it's easier to divide or multiply by 10 because 10 is the base. So in this example, let me illustrate uh, the, the characteristic of floating a binary point. Okay, so for example, if you have a value of 1.5 in decimal, 1.5, okay, the equivalent in binary is 1.1. Why is that? Because we have zero point 0.5 and 0.25. Just divide it by 2. Okay, so uh, okay, and this is 1, for example. No? We'll insert a column, which is our binary point. Okay. To have a 1.5, you will have a 1 here and you will have a 1 here. So if you multiply them together times this, okay, and then you copy this, and you just sum them together quickly. Sum, okay, press enter. We have a 1.5. Okay, now that is why it's 1.1. If we divide this by 2, no, equals this divided by 2, we have 0.75. How do we divide a binary number by 2? We can do that by floating the binary point. If we float the binary point to the left, it divides it by 2. Let me illustrate that. For example, we will insert the column. Okay. And now we will place the binary. I'm sorry, here now. We'll insert the column here. We'll delete this column. And then we will float this one to the right, rather to the left. Okay. What we'll do is we'll float. We'll undo that. We're supposed to delete this. We'll float the binary point to the left. So we insert one column and then we copy this. Then we remove this. Okay. So now this will be 0.5 and this will now be our 0.5 instead of 1. This will be now our 0.5. This will be our 0.25 because we're going to the right, and this will be our 1/8, like that. So if you will sum this, okay, if you will sum this will be 0. If you will sum this, because we have floated our decimal position or rather binary position to the left and get the sum, okay, you will get 0.75. That's actually dividing it by 2. I hope you follow, no? So dividing a binary number by 2 is much easier than dividing a decimal number by 2 because we just float to the left. Okay, floating to the left will divide by 2. At the same time, multiplying a binary number by 2 is easier than multiplying a decimal number by 2 because we are just going to float to the right. Okay, so let's convert our example right away. This is our 2134175. If we'd like to convert this into floating point, okay, what we'll do is we'll float our binary point to a position where the integer part is already 0. This is the first position where the integer part is 0, which is here. Okay, so we'll float until this point, so which means we will count the floating point. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12, because we'll put our binary place here. Okay, so what we'll do is we copy this. Okay, we copy this and float it to a position after the binary point, which is here. Okay, now if you count that to the last, we will already delete this. Okay, if you count that up to the last, so how we have how many counts did we, did we float? Let's do that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we floated then 12 times, so our exponent is 12. Let's try a 5-bit exponent, which is 12. Okay, let's put it here. And what will be the binary value in 5? That will be 0, 1, 1, 0, 0. Is that correct? Let's find out. 1, 2, 4, 8. Yes. No. So this is 12. Because to have a 12, we'll have an 8 and a 4. I hope you follow. We have an 8 and a 4, and that is 12. Our mantisa, which is 10-bit, is, okay, a concatenation. We'll concat a binary, okay, followed by this. Concatenate. It should be concatenate, no? We'll just check that. Okay, we have a 10-bit mantisa. So there's an error because concat is an Excel formula. Okay, we'll have to change this. What's that? No. Okay. We lost it anyway, so we'll just type it again. Concatenate. Okay. We'll put a binary point and we'll concatenate it again, starting at this point. Anyway, we'll just remove the, this is the formula. We'll just remove the decimal point. It's not needed. Okay, so that's our mantisa. Okay, this is our exponent, this is our mantisa, which is much easier than if we did decimal first. I hope you follow. It's much easier to convert a fixed point number into a floating point number because we are just going to float the binary point to the left until we have a fully fractional mantisa. And the number of times that we float, our binary point becomes our exponent. Okay. Thanks everyone for watching, and see you in the next video.